Okay, look. In the last class, we have discussed about chemical reaction and equation. Hello.
Yes, sir.
So in this chapter, we will learn this many things. This is the introduction. What we are going to learn in this chapter. Then we learn there are two types of changes. Two types of changes. One is physical changes, and another one is chemical changes. What is the difference between physical and chemical changes? What is the difference between physical and chemical changes? If
In chemical changes, new product is formed.
yeah, no. If chemical composition is happening, if change in chemical composition is nothing but chemical build-up, then we will tell this is a chemical reaction. Otherwise, it is called a physical reaction. If there is change in chemical composition, then that is called chemical changes. If there is no changes in chemical composition, that is called physical changes. Okay. Then we learn. In physical changes only shape, size, physical properties, which is called physical properties. Okay, state of the matter, size of the matter, color of the matter only changes. But in chemical changes, chemical composition is change. Chemical composition means build up the substance in which the build up they will change. Okay. One of the example is burning of a paper. Burning of a paper is one of the example of a chemical changes, and the process through which chemical changes occurring, that is called chemical reaction. Chemical reaction is the process through which chemical changes is occurring. Okay.
Okay, sir.
Then we learn some example, like here melting of ice is a example of a physical changes. Boiling of water, physical changes. Why? Because there is no change in composition. There is no change in composition. Composition means water is formed by hydrogen and oxygen. Look, in ice also hydrogen and oxygen, in water also hydrogen and oxygen. Same composition. Only change in state. And you know the change of a state, color, size is comes under physical changes. But you look combustion of a charcoal. Combustion means any substance that react with the oxygen to form carbon dioxide, heat and light. Okay. And those substances are called combustible substance, like wood, like paper. These are combustible substance. So here is charcoal is nothing but one form of a carbon that is react with the oxygen to form carbon dioxide, heat and light. Here look, carbon is a element, oxygen is a element, and combinedly they form carbon dioxide. Look, change in composition na. That's why it is called a chemical reaction. Then we learn how to identify chemical reaction is happening. Change in color. Characteristics means this identify whether a chemical reaction is going on or not. Number one, change in color. Barium chloride and sodium sulfate. These are the two solution which is colorless. When they react with each other to form barium sulfate and sodium chloride, look, barium sulfate is white color. The color change is happening na. Okay. Then formation of a precipitate. Precipitate means insoluble solid. Look, two solutions are mixing each other for forming one insoluble solid. This insoluble solid is called the precipitate. Precipitate is nothing but insoluble solid formed after chemical reaction. Okay.
Okay, sir.
Then we learn evolution of a gas. When chemical reaction happening, that time evolution of a gas means gas is released. Okay. Look, when sodium hydrogen carbonate react with the acetic acid is called a vinegar. Baking soda is the common name of a sodium hydrogen carbonate. This is sodium hydrogen carbonate. This is acetic acid whose common name is vinegar. When they react with each other, they form sodium acetate and H2CO3. Then this break down to form hydrogen and a carbon dioxide. Look, only focus on carbon dioxide. A gas na? A gas is evolution na?
Yeah.
And look, the next one is change in physical state. Look, baking soda is a solid, vinegar is a aqueous. But when they react with each other, water is forming which is liquid. That means change in state na? And gas also change in state. Then come to next thing, change in temperature. Actually, change in temperature two types. Either heat is released into the surroundings, otherwise heat is consumed to the
Surrounding.
consumed from the surrounding. If heat is released, it is called exothermic. If heat is consumed, it is called endothermic. Okay.
Okay, sir.
Then come to example of a exothermic and endothermic reaction. Burning of natural gas. Burning of a natural gas. Look, combustion. Combustion is the process through which one substance react with oxygen to form carbon dioxide, heat, and light. Okay, combustion is of two types. Combustion is of two types. One is burning and one is spundling. Spundling. Okay. Burning means the light energy gives flames. So what's burning of a candle? When candle is burning, they provide flame. But think about matchstick. When matchstick is
Yeah.
burning, that time don't tell burning. That is smoldering. Smoldering. Okay, because it is only glow. Don't provide any flame. Okay. So look, when methane is a combustible substance. Combustible substance means that react with oxygen to form carbon dioxide, heat, and light. Okay. Look, methane react with oxygen to form the product with this heat and light is releasing to the environment. When heat is releasing to the environment, that is called exothermic. That is called exothermic. Here you look, respiration is also example of a exothermic. Look, energy is released na, and you know in exothermic and endothermic, not only heat but also different types of energy like heat energy, sunlight, sound energy also released. Okay.
Uh,
Then come to another two example and remember, but photosynthesis is an example of a endothermic. It is not exothermic. Endothermic means heat is consumed by the heat is consumed from the environment. Okay.
okay, sir.
Then we started balancing and need to balance chemical equation. Look, first before starting balancing, we have to understand chemical reaction means when chemical changes through one process called the chemical reaction. Chemical changes are happening through a process called chemical reaction.
Reaction.
Chemical reaction, to represent chemical reaction in shorter format, we have two way.
Two.
One is word equation, one is
Word equation.
and next one is
Chemical equation.
chemical equation. Okay. But in both these cases, something is common. Some things is common called there is a aromatic. Left hand side to the aromatic is called reactant. Reactant means which are undergo in the chemical reaction. Product means which are the substance that are formed after a chemical changes. Okay. The substance that undergo chemical changes are called reactants. The substance that are formed after the chemical change are called the product. These are called product. Remember, heat and light are not product. They are energy, not matter, not substance. Okay.
Okay, sir.
Then chemical equation. Chemical equation is nothing but the shorter, faster of representing a chemical reaction in terms of symbols and formula to different reactants and product is called a chemical equation. Okay, you know na, hydrogen can be written as H, helium He, lithium Li. These are called symbols and formula like H2SO4. Okay,
Okay, sir.
that first thing. Look, magnesium is burning in presence of oxygen. How we write? Magnesium symbology Mg, oxygen symbology O2, and it form MgO, magnesium oxide, plus heat and light, This is nothing but chemical equation. Okay. And sir, is the above chemical equation balanced? Then what do you mean by balanced? Balanced means the number of atom on LHS should equal to number of atom on LHS. If yes, then it is a balanced chemical equation. If no, it is a skeletal chemical equation.
Equation.
Chemical equation. Okay. After writing chemical reaction, we have to look whether it is balanced or skeletal. If skeletal, convert it into balanced. Balance means number of atoms on LHS should equal to number of atoms on RHS.
RHS.
And the need to balance a chemical equation. Yesterday we have discussed the law of conservation of a mass, law of conservation of a to maintain law of conservation of a mass. Law of conservation of a mass is this is given by Antony Lawrence Lavoisier. Okay, it is given by a scientist Antony Lawrence Lavoisier. Okay, according to this rule, in a chemical reaction, mass is neither created or destroyed. That means if AB and CD are two reactants react with each other, they form AD and CB. Only changes in arrangement of atoms. New atom never be created. Okay. Suppose here I am magnesium plus oxygen. We create magnesium oxide. Here you look. Here magnesium atom 1. Here 1. But here oxygen is 2. But here oxygen is 1. So we have to balance it. Balance it. Because according to law of conservation of a mass cannot be created or destroyed in a chemical equation. So what happening in chemical equation? Only atoms are rearranging.
Yeah.
Okay. Then atoms means suppose 3 atom. Their mass. 3 atom. Their mass. They should be equal. If atom increase 3 to 4, that means mass will increase, na?
Yeah.
If atom decreases 3 to 2, then their mass should be decreased, na? So we have to balance the chemical equation. Okay. Then how to do? Is the below chemical equation balanced? Look. Iron react with water to give iron oxide and hydrogen gas. Is it chemically balanced? Look. In left hand side, how many iron atoms are there?
One. No.
One. Yeah.
1.
In left hand side, 1. In right hand side?
3.
In left hand side, hydrogen?
2.
Right hand side?
2.
Oxygen?
1.
Right hand side?
4.
Are these equation chemically balanced? No. It is a skeletal. Chemical reaction. Sorry, chemical equation. Then we have to write it in a how to do? By heat and trial method. Trial method. Look how to do. Step number 1. Write the chemical reaction in words. First you have to write in words. Okay. So iron, you know na, Fe the symbol of iron, plus steam. Steam is nothing but water. When you heat the water, that becomes steam. Okay.
Okay.
Water has 3 forms. One is water, one is ice, and one is steam. Ice is in a solid state, a gas is in steam is in gas state, and liquid is in water is in liquid state. Okay. So first step number 1, we have to write the chemical reaction in words. So iron plus steam equal to magnetite. Magnetite is nothing but iron oxide. Okay. Plus hydrogen gas. Then number 2, writing the chemical reaction in the form of a skeletal chemical equation. Okay. Skeletal means from word to convert it is symbol. Iron plus steam, iron oxide, also called magnetite. Remember, iron has a two valence. One is Fe2 minus 2 plus, one is Fe3 plus. Okay.
Okay.
So look, in this chapter you are not learning about reaction, how to write reaction. This is the upcoming chapter. In this chapter we are introducing about chemical reaction, how many type, how to write. Okay.
Okay.
Then step number 3, enclose the chemical symbols and formula in boxes. Look, after writing this, you have to enclose inside box. Okay,
Ah,
why you are enclosing? Because look, this ensure the subscript of the symbol or formula is not changed in order to make the number of atoms the same on both sides of the chemical equation. That means if someone look, this is the skeletal equation.
ah,
Look, Fe plus H2O, it gives ferrous oxide plus hydrogen. This is the skeletal equation. Suppose I am writing 3 here. That's why it's wrong. It's wrong.
wrong.
You can write here. You cannot write here. You can write here. Okay? To ensure that we don't write in subscript. That's why we are making boxes. Then list the number of atoms of a different element. Okay, look, this is the skeletal equation. Iron, hydrogen, oxygen. Three elements are there. Okay, look the reactant side. How many iron atom are there? How many?
Uh, uh,
Here how many?
one,
One. Iron means Fe. How many hydrogen atom?
two,
How many oxygen atom?
one,
In the right hand side, how many iron? 3.
three,
Hydrogen 2. Oxygen
two,
4.
four.
Then look, start balancing the compound reactant product that contains the maximum number of atoms. So you have to start the balancing from any side, but the condition is that should contain the maximum number of atoms. Here iron how many? 1. Hydrogen oxygen 3. Here iron and oxygen 7. Hydrogen 2. Then which element or compound having highest number of atom? This one.
Ah,
You understand or not?
understand, sir.
In that compound, balance the element with the maximum number of atoms. Look, in this entire skeletal equation, our Fe3O4 having highest number of atoms, that is 7.
Yeah,
In this compound also, oxygen having
highest.
highest. So first you should maximum number of atom. Following this criteria, the compound will be Fe3O4 and element will be O. So first we have to balance the O. Okay, in right hand side how many oxygen are there? 4.
Uh,
4. In left hand side how many are there?
two,
Hmm? Oxygen
one, one,
1. Then how to do? 1 into 4.
four.
So here you have to write 4. Don't write here, subscript don't write 4.
Okay,
Okay, look, now oxygen is balanced. Now oxygen is
balance.
balanced. Then come to hydrogen. Here how many hydrogen are there? Sorry, in right hand side how many? So left hand side
Yeah,
2 is
two,
2, but to balance oxygen we multiply 4 na, it become 8.
yeah,
So this side also you have to multiply by 4.
becomes eight.
Then come to iron. In left hand side how many iron are there? So right hand side 3.
Three,
In left hand side 1.
one.
Now it becomes balanced. Look, same thing we are doing. Look, here 3 there. First we took the compound that having highest number of atom, that is this one 7. Then from this compound we took the we took the element which having highest atom, that is oxygen. And first we look in right hand side 4 oxygen are there. In left hand side 1. So to balance it we multiply by 4. Multiply by
Four.
4. Then write 4 here. Then after completing oxygen, then come to hydrogen. Hydrogen how many are there? 2.
Uh,
2. Right hand side 2. Left hand
two,
side actually 2. But for balancing oxygen we multiply by 4 na. That's why it become 8. So right hand side we multiply 4. Are you understand?
sir.
This is how you have to do. Okay. then limitation of a chemical equation and their removal. There are lots of limitation on writing chemical equation. We have to read each and every one and try to solve this. Try to solve it. Number one, physical state. Look, by looking this reaction, are you understanding? Iron is in which state? Water is in which state? This iron oxide is in which state? Hydrogen is in which state? You know na? Iron is solid. Water is liquid. This is also solid. This is a gas. How you understand? How you understand? Look, for this we write some symbol. For solid we write S. For solid we write subscript S. Liquid L. Liquid L. Gas G or this arrow mark, upper arrow. Okay.
Okay.
Aqueous solution. Aqueous means water as solvent. Aqueous. AQ. AQ.
Active.
Precipitate. Precipitate means insoluble solid. Either we can write PPT, otherwise down arrow, otherwise solid. Okay. This is how we write to understand the elements is in which state. Then look, what we are doing here. First word equation. We converted this word equation into skeletal chemical equation. Then balanced. Then make it informative. How to make it informative? By writing the state. By writing the state. Look. Suppose I am taking one example. Zinc plus sulfuric acid plus zinc sulfate plus hydrogen gas. It is a skeletal equation. Skeletal equation. Zinc plus sulfuric acid. Okay, zinc is nothing but a metal. Zinc is nothing but a metal. Sulfuric acid is a acid. You will learn everything in upcoming chapter. You will learn everything. Zinc sulfate is nothing but a salt. When a metal react with acid, that time they give us salt and a hydrogen gas. Salt and a hydrogen gas.
Yes.
Then how to write it? How to write it? Look. Remember the four steps. Four step are there. First, word equation. Word equation should convert it to skeletal chemical equation. Then balance. Then informative. Then look here. This is word. Then this is skeletal. Okay. After skeletal, then look to convert it chemically. How many zinc are there? Here 1. How many hydrogen? 2. How many sulfur? 1. How many oxygen? 4. How many zinc? 1. Sulfur? 1. Look the subscript. Oxygen 4. Hydrogen 2. Look, zinc 1. Zinc 1. Correct. Hydrogen 2. Hydrogen 2. Sulfur 1. Sulfur 1. Oxygen 4. Oxygen 4. That means already it is in a balanced form. Balanced form. Then make it informative. Then make it informative. How? Zinc is a solid. Zinc is a solid. H2SO4 is aqueous. Aqueous means, remember, it is a acid. Okay. We don't react acid directly. We put in water. We put the acid. Then we react. Okay. That's why it is aqueous. Aqueous means soluble in water. Then it will give you zinc sulfate. Then you give it a zinc sulfate. It is also aqueous. It is a salt. Okay. You will learn everything. Why this is acid, this is salt. You will understand everything in the upcoming chapter. And the hydrogen gas is emerging. Okay. Then look. For gas, we are writing G or this mark. Now look, by looking this, you understand na? Zinc, which is a solid. Sulfuric acid, which is aqueous. When they react with each other, they form zinc sulfate, which is aqueous, and the hydrogen gas is releasing. Sir, how I know which element is in which state? Okay. So here are some information to know reactants and product, state of reactants and product. Otherwise, you can say element or compound state. Okay. Then look. Metals are found in solid state at room temperature, except mercury. Metals you will learn in metal chapter. Metals, those give electron to become positive ion. Okay. Metals are those substances who give electron, who donate electron to become positive ion. So at room temperature, mean 25 degrees Celsius, metals always in a solid state, except one metal, that is mercury. Except one metal, that is mercury. So look, lithium solid, sodium, magnesium, aluminum, potassium, calcium, iron, silver, gold, copper, zinc, lead, all are in a solid form except mercury. So you have to remember, when metal is coming, write solid. Okay.
Okay.
And remember, mercury is the only one metal that is in a liquid state at room temperature. Room temperature means 25 degree Celsius. How to identify physical states of this time non-metal, this time non-metal. For all metal are all generally in a solid state except mercury, and non-metal are generally found in a three physical state. Metal only one, that is solid, and only mercury is the only one metal that is found in a liquid state. But if you come to non-metal at room temperature, then three states are there, like oxygen is in gas, nitrogen gas, hydrogen gas, chlorine gas, gas. But look, bromine is the only one non-metal that is in liquid state. Okay, you have to remember, bromine is the only one non-metal that is liquid state in room temperature, and iodine and carbon, that is in a solid state, state. You have to remember. That means we understand some metal always found in a solid state at room temperature, only one thing except mercury, and non-metals in three state. Then come to another thing, that is some compound are found in solid state at room temperature, and when we heat and melt, they are converted to liquid state, and also if they are soluble in water, they are aqueous solution. Look, suppose sodium chloride. When we give 800 Celsius, when we boil this sodium chloride, when you heat this sodium chloride to 800 degrees Celsius, it is convert into liquid form. Or molten form. Then when you dissolve sodium chloride, it become aqueous solution. Okay. Look, at room temperature they are solid, but when you increase the temperature, they become molten, or otherwise say liquid state, and when you dissolve in water, it become aqueous. Then how to identify? Okay, next. Some compound are found in a liquid state or gaseous state at room temperature. Like look, water. It is found in liquid state. It is found in a liquid state. At room temperature, it is liquid. Carbon dioxide, room temperature, gas. Ammonia, room temperature, gas. Sulfur dioxide, room temperature, it is a gas. Hydrogen sulfide, room temperature, it is a gas. You have to remember. And remember, at room temperature, water is in liquid state. But if you provide heat, it become vapors, water vapors or steam. It is the gaseous form of water, and ice is the solid form of water. Okay. Then then next one. Some compound are insoluble in water and hence form insoluble solid, that is precipitate. Some compound are there, they are insoluble. Look, sodium chloride, it is soluble in water. But if you look, barium sulfate, it is insoluble. Lead iodide solid. Calcium carbonate solid. Silver chloride solid, copper sulfate solid. But you have to remember the color also. Barium sulfate is white color. Lead iodide, its color is yellow. Calcium carbonate white. Silver chloride white. Copper sulfate black. You have to remember the color also. These are the compounds which are insoluble in water. That means it is 100% form precipitate. It is 100% form precipitate.
Precipitate.
Then come to concentration of an acid. These are we are learning how to make our chemical equation informative. Okay, look. There are two types of acid here. There are two types of acid here. There.
Yeah.
Acid means it gives H plus ion in water. Two types of acid here. That you will learn acid and the base chapter in upcoming chapter. Okay. Two types of acid are there. One is concentrated acid. One is concentrated acid, and another one is diluted acid. Diluted acid.
Acid.
Concentrated acid is written by CONC dot in chemical equation. Dilute by DIL dot. Concentrated acid is nothing but has more amount of acid particles as compared to diluted acid containing some volume of solution. Suppose I have 100 meter cube, 100 milliliter acid, 100 milliliter acid. Okay, I have. If I tell I have 100 milliliter diluted acid and 100 milliliter concentrated acid, then in these two same volume, but the acid part is more in concentrated acid. Concentrated acid having more acid part, more acid particle. Okay.
Okay.
If volume is same, concentrated acid having more particle than diluted acid. Okay. Look here. One example, metal. Suppose zinc is a metal, and you know metal are generally solid in room temperature. Diluted acid. Look, diluted acid. H2SO4 is a diluted acid. When react with this, they form zinc sulfate and H2. Then look here. How we write diluted sulfuric acid? DIL. Okay? You understand or not?
Okay.
Then heat changes accompanying a reaction. When heat is changing, how to write? How to write?
Understand.
Number one, exothermic. We have two types of reaction, na, on the basis of a heat. Either heat is releasing, or heat is observing, or heat is observing. If heat is releasing, that means exothermic. If heat is consuming, that is called endothermic. Okay. Then look,
Okay.
when heat is produced, how to write? When heat is consumed, how to write? Look, there is a reaction. Look, this is nitrogen. Nitrogen is a non-metal. Okay. When nitrogen react with oxygen, yeah. Hello. Is my voice clear? Hello. Hello. Hello.
Yes, sir.
Is my voice? Look.
Can
Look. It is telling when exothermic or endothermic reaction is happening, how to write heat is consuming or heat is releasing. Okay. Look. There is a endothermic reaction example. Look. When nitrogen react with oxygen in presence of a heat, lighting, because nitrogen is available in air, oxygen is available in atmosphere. When lighting is happening, it forms nitrogen monoxide. Look here, heat is consuming. How to write? Plus heat. Okay. In reactant side, you have to write heat. Otherwise, you can write here also. Okay. I forgot side one thing. Just a minute. Load. Then look. Optimum condition to yield a product. Okay. Look, reactants, temperature or pressure, then products. What do you mean by catalyst? Here you look. Sometime temperature or pressure is required to make the reaction. Sometimes sunlight. How to light sunlight? You can write that in word sunlight or H new. H new. Okay, this is called new. To represent heat, you can write delta. You can write delta. For electricity, you can write electricity that. Sir, what do you mean by catalyst? These are called catalyst. This sunlight, heat, electricity, temperature and pressure. These are called catalyst. These are called the
Catalyst.
optimum means increase or decrease the speed of a chemical reaction. Speed of a chemical reaction.
Reaction.
Okay, look. When sunlight is required, we write new. When heat, delta. Look. Few seconds ago, I am telling nitrogen react with oxygen.
Yeah.
Okay. In presence of a heat. How much heat it required? 500 degrees Celsius. And 200 atmospheric pressure. In presence of iron. These three are nothing but your catalyst. To form ammonia. Okay. Catalyst may be temperature, pressure, sunlight, heat, electricity or any other element. Like here, iron is a catalyst. Okay. When nitrogen gas react with a hydrogen gas in presence of a 500 degrees Celsius heat and 200 atmospheric pressure in presence of a Fe. Okay. Then what do you mean by catalyst? What do you mean by catalyst?
Catalyst.
Okay. Catalyst is nothing but a substance. Catalyst is nothing but a substance that increase or decrease the rate of the reaction without itself being consumed in the reaction. Means it is helping increasing or decreasing the speed of the reaction. Okay. Without itself being consumed in the reaction. They don't participate in the reaction. But they will increase the speed of a reaction. Okay. Catalyst are those substances that increase or decrease the rate of a reaction without consuming the reaction. They don't consume in the reaction, but they will increase the speed of a chemical reaction. Okay. Like in previous example, look, iron is the catalyst. They increase the reaction. Two types of catalyst are there. How many types of catalyst? Two types. One is positive catalyst, one is negative catalyst. One is positive catalyst, one is negative catalyst. So what do you mean by positive catalyst? It increase the speed. It increase the
Speed.
rate or speed of a reaction.
Reaction.
Suppose A is a substance, P is a substance. Okay. So this positive catalyst increase their rate of a reaction. Suppose it take to react, it take 3 hours, but this catalyst is help to form it in between 15 minutes. Okay. The catalyst are those substances that increases the rate of a reaction. Okay, increases or decreases also. Positive catalyst are increasing, negative catalyst are decreasing the rate of the reaction. Okay. Then some example of a positive and a negative catalyst. Look. Formation of ammonia. Few seconds ago we understand na. Nitrogen react with oxygen in presence of a 500 degree Celsius and 200 atmospheric pressure in presence of a Fe to form ammonia. So here this iron is doing like a positive catalyst. Is doing like a positive catalyst. Means it increase the speed of reaction. It increase the speed of a reaction, rate of reaction. But if you come to decomposition of hydrogen peroxide, here phosphoric acid, here phosphoric acid, which is symbol is H3PO4, it is a negative catalyst. You have to remember at least one example of a positive and negative catalyst. Fe is a positive catalyst, H3PO4 is a negative catalyst. Okay. Formation of ammonia. Formation of ammonia requires positive catalyst. Decomposition means this H2O2 hydrogen peroxide is break down to give you some product. Okay.